Well, we're going to look at Snell's law here. And again, this is a mathematical way to relate refraction, or the bending of a light wave due to a change in speed from one substance to another. Put the formula in here. What this n is, we should probably write what this is. The lowercase n, and let me see if I can get my pen here. The lowercase n, that is the index of refraction. The index of refraction. This index of refraction is how much a light wave will bend or slow down as it goes from one medium to another. The greater n is, the greater the bending. Of a light wave, the greater the bending, and then the more it bends, what that's really saying is the greater the decrease in the speed of light. Or the speed of the wave, if you will. We'll call it the speed of light here. Because typically when we talk about the bending of a light, talk about bending of a light wave goes from one substance to another. So what ends up happening here, let me get a different color here, is here's our angle of incidence right here. So it's moving up here, and again, if you remember, this is the normal. So as it hits this, and this material this is probably water and has a certain index of refraction. As it hits the next layer, the layer above it, you have this angle of refraction. This is probably air. And so what Snell's law is saying here, that this angle index of refraction equal the index of refraction and the angle of refraction on the refracted ray, I guess, and this would be the incident ray. So you have this formula here, n1 sine theta, and again here's theta again from the normal to the incident ray, and that equals the refractive index of whatever material this is, and then the sine of the angle that's formed here. You do have a page of problems on here. Essentially, got to know how to punch in sine and the inverse sine. And again, it's pretty straight algebra. n1 sine theta equals index of refraction second substance, the sine of this substance here, and hopefully you can solve. You got to have three of the unknowns. That's pretty much it. The index of refraction of water, and this makes it, index of refraction of air is 1.00, and so that typically makes things a little bit easier. See if I can get that out of there. Yeah, the index of refraction of air is 1. It makes life a little bit easier. So you do have some problems. If you look on your Moodle, and I believe I also put an answer sheet there. We're not, again, when you guys take physics, you'll get into this more detailed. But here we're just kind of introducing this whole concept, and again, work on your mathematical skills a little bit. So on the last video on this this series, we're going to look at the Doppler effect.